little bit less basic. I'm going to run a train over you in this session. So my name is Clemens. I work for Microsoft. I'm the lead architect for all the messaging services that we have in the Azure cloud, Event Grid, Event Hubs, Service Bus. Azure Stream Analytics is also part of our family. And we, as a team, are also responsible for the event streaming capabilities in Microsoft Fabric. The data platform that we have, so Event Streams, is a capability that's built in there, and that is an app. That's how I explain it. An app that we built using Event Hubs, using Stream Analytics, using Event Grid now to kind of make message streaming in general, easier. And that's a journey. We're not at where we want to be yet in that journey, but it's already showing that it makes it possible for relatively normal people who can write Python programs, to publish event streams and then land them in a database and then work with that database and create dashboards. And I'm going to show you that a little later. This talk is about metadata. I have been spending my last 2 years mostly with metadata and thinking about how can we go and create better, meaning more robust experiences with streams, and how can we take the brittleness out of streaming. Because in streaming applications, many applications are very bespoke, and many applications are very brittle because they tend to be distributed across many teams, but those teams don't necessarily have a good metadata foundations to go and use. And it's not enough to just exchange schemas of events. You need to take this a little bit further. You need to go and standardize even more. So I'm coming to you talking about some standards that are emerging, that I've been working on with others, obviously. And I'm going to talk about the problem of metadata in general. So where are we? We have tons of powerful tools, event stream engines, event stream processors, lots of interesting, and event stores, lots of interesting stuff. And generally, when we're writing events, we're writing events kind of as these, in Python programs, kind of we fill a structure, and then we push that structure around. Even though those programs, those tools are really great, integration across a pipeline remains really hard. So what does a pipeline look like? We have a producer which is producing these events. And then there's a broker that takes those events. May that be EventBridge, may that be Kafka, may that be Event Hubs, whatever. Then there's some kind of stream processor, there's a serverless function, there's a connector that then goes and pushes the data into an event store. The event store then serves up visualizations, but the visualizations may also be updated from the broker directly for real-time updates. And all of these pieces need to understand that code. They need to understand the structure that has been pushed into the top of the funnel at the producer. And the question is, how do we communicate this? Today, what I'm seeing is event streaming setups work because there's a team that is using tribal knowledge to kind of communicate the data structures kind of between those tiers. Now, the problem with those structures is that we have different encodings, we have different shapes in which we transfer these things, and we ultimately need to land this data in stores that have different shapes and different schema requirements. We need to go and do those translations. So there's always breakage between these things, and that makes it really hard. So we have that problem, and that's why I introduced this with, hey, we're building Fabric, is that our goal is to get data from the left and move it to the right, where the right is often the database. And the database needs to have a schema. So I start with some Python program that someone writes, and now I need to go and make a database out of that. And that's difficult. And what we all do as developers is we write the Python program, we configure the pipeline, we configure the mapping to the database, and it all works. As soon as you do this with 2 or 3 people, you better talk to each other. If you want to do this across teams, holy shit. So that's hard. A pipeline would be much better if we would declare ahead of time in a consumable format, in a toolable format, how all of these pieces can get their information. And it's not just about the data structures, right? We are at a place, yes, there are schema registries, and the schema registries exist primarily to allow for metadata to be left off the wire. So you can go and use Proto, you can use Avro, you can use those encodings because they are super efficient. But if you use those, then the producer and the consumer must have a place where they can go and exchange that schema. That's the primary purpose of the schema registries today. But that's not enough. Because we also need to understand, and that's something that came in the keynote, right? We need to categorize events. We actually need to discriminate events. We need to keep them separate. Because if you want to be efficient, you cannot run, you have 20 types of events that are being raised by your application. You cannot make 20 Kafka topics for it. I mean, maybe you can, and maybe some of you do. It's just crazy. Because you are then running 20 times the replication for those topics and 20 times the partitioning and all that nonsense. Of course, you want to multiplex. But if you multiplex, then you need to be able to kind of keep those things apart. You need to understand what are the events that are coming through this one pipe. And how do I find that out? What is the contract for this stream? And contract here does not mean what async API tries. Meaning, I throw something into this queue, and then I wait, and something comes out of another queue. And that's an API call, somehow. That's not the point. We need to have formatting for event streams. We need to be able to do to an event stream what we do to a database. Metadata for messaging, metadata for eventing, is exactly the same what we do with schemas for tables, but it's not data. It's not schema for data you have, but it's schema for data you don't have yet. So the data comes down that pipe, has to go and conform to that contract, then it's valid. And the data you push into that channel needs to conform to that contract. How do we form that contract? Well, it turns out there is nothing. Because something like an API structure doesn't tell you all the things you can go and multiplex through a channel. There is no such thing. So we decided that we need to go and build a thing like this. Let's talk about, but before we get there, that's going to be the X registry discussion. Let's talk about metadata from the ground up. Let's start with schemas. We have layout and data types. These are the obvious parts. And then we have semantics and documentation, which kind of are pushed to the side, and many people don't really pay attention to the description field. And to further type annotations, format in JSON schema, for instance. Why are those important? Because now, and even more in the future, your code will increasingly not be written by you, but by some LLM. And that LLM needs context. And the more context you can give that to that LLM, the better it is. And if I give you a schema, and the schema has a field, and that field says temperature, it's a number. What does that mean? Is that Kelvin? Is that Celsius? Is that Fahrenheit? It's kind of important. You can take anything like volume, length, and there's always an implied notion of, I know what this is, but the LLM does not. And the LLM may come from America. So it may have completely skewed ideas about Fahrenheit and, here's cultural imperialism brought to you by your LLM that you're using, just because of what it was trained on. So we need to have more precision. And we need to have descriptions, because descriptions help. So schemas are not just for making Avro work and making protobuf work, but we need to have schemas for JSON. We need to have schemas for XML, particularly because they bring the extra context. That's why schemas matter. So in many scenarios where you have so far not used schemas, you will use schemas just because they bring that extra context that is not on the wire, even if you're using JSON. Constraints are great. I've been coding, many of you, all of us, are somehow coding in some way, probably with AI already. I've been doing this now for 2 years. What I'm learning, I'm writing pretty insanely complicated stuff with AI now, where I give it 15 pages to read, and then say, you go and do this. And the more constrained things are, the better you have things described. Like the X registry specification is fantastic for this. The better is the result. Requirements count. So the more context the LLM gets, and if it has a big context window, the better it gets at it. They're also ultra great at transformations. So if you need to go from one structure to the next structure, give it both structures, give it the data you want to go and transform, and it's going to do a good job at it, because they're transformers. And I said, standardization is really great, also for those LLMs, because they do better if they can focus on one thing, if they can focus on one target. And that's why standardization reduction is going to help us build better applications using these agents and LLMs in general, and keeps agents operating in a more predictable way, because if you spread out the complexity too far, that's going to be harder for them. So let's get to the schema section. Good and bad choices. That's what I call this section. First, let's talk about the thing we all love. J in JSON schema stands for joy. Everybody who has worked with JSON schema, in all seriousness, for more than 2 weeks hates it. And the reason is, it has constructs that you can't map to anything. It's a schema, it's a validation language. It's actually a pattern matching language. You take a JSON document, you run it through the pattern match, and out comes yes or no, which means is this conformed or not. What we all tend to do is we tend to use it as a data definition language. But it is terrible as a data definition language, because it has all kinds of compositional constructs, all of, any of, and etc., that people try to use in data definition constructs, but they make the schemas unmappable to programming languages. If you take, for instance, the OpenAPI tooling set, that can actually handle JSON schema and OpenAPI, because OpenAPI is using JSON schema. And you take a complex schema, JSON schema with a few any-of and a few all-ofs and all that, and there's like 10, 12 different languages, and you run that through those tools. Every tool gives up at a different point. They all give up, but they give up at a different point. And none of them yield a consistent, predictable outcome, because it's too hard. And so that's a problem. And we had to decide, what we're going to do for Fabric. What are we going to take? Are we going to take JSON schema? It's the popular thing. Everybody's using it. And we're all like, maybe not. Because you have absolute references for external schemas in $ref. You have to watch out for external resolution of stuff everywhere. You have these all-of definitions of 3 types. Well, how do I deal with that in my program, right? I can't do multiple inheritance in my classes. I have these any-offs with weird. This is all taken. All these complications are all taken from real scenarios. It's just difficult. And if you write a code generator and you're not testing against everybody's weird ideas about JSON schema, which are all valid, the thing is going to fail. And you need to have a resolution strategy for it. One alternative is Avro schema. We're using Avro schema internally inside of Fabric now because we had to ship something. And the nice thing about Avro schema is well known in data quarters, right? And it has the additional wonderful quality that you can drive binary serialization with it. But you can also use it to kind of describe your data structures, and then you simply ignore the weird serialization rules of of Avro for JSON, and you just serialize it down as if you would. Like if you don't know about the weird serialization rules of Avro schema of Avro for JSON, then you will do the right thing. Just don't read the spec. So we're using that because it's self-contained, doesn't have external references, allows namespacing, maps wonderfully to programming constructs, maps wonderfully to databases. So that's the choice that we made. As I said, this JSON encoding is terrible. We have a proposal to fix this. There's unfortunately nobody at home in the Avro project who would kind of do strategic decisions of that sort, so that's kind of difficult to get in. But still, we have to standardize on something we have decided we can't standardize in JSON schema. So our current choice is we're going to pick Avro. Now, and then we've been thinking about this a little bit further. This is JSON structure. JSON structure, living at jasonstructure.org, is a proposal that we're about to put into the IETF as an internet draft. I've presented this already twice at IETF meetings. People were very liked it, and it's a reformulation, refactoring of JSON schema. Because the people at Microsoft who do OpenAPI are unhappy. Because they have a dependency on JSON schema, and it's driving them mad. Because the tools are just terrifyingly fragile because of the unconstrained nature of JSON schema, and because of the type system problems that it produces. So they need to have something better. Other people like us who need tooling are also annoyed. And if you ask around in the community, lots of people are annoyed. So JSON structure is a set of 6 specs that compose, and where the core is fairly simple and has the same qualities as Avro in the sense that it doesn't have external references and it has a good type system. So let's look at this. This looks like JSON schema, and that's intentional. I'm requiring that there's a type. It's not required in JSON schema. In JSON schema, it's implied that it's a type. But with that, you can't do proper namespacing. So I'm requiring that it's a type. I'm requiring that you have a name. There is no name in JSON schema, because they don't care about type definitions. They only care about pattern matching. And for pattern matching, name is just useless. They have a title, but that's just another thing. So we have a name. And that name is constrained, as are all the property names. Those property names cannot have an at in it or a backtick or whatever nonsense, they must start with a character or an underscore, and that's it. And then they must follow rules that map nicely into column names in databases, into variables in programming languages. That's the constraint. Then we have a way to go and create alternative names to go, if you want to go and do something fancy, you can go and do it. But this looks like JSON schema, but it has a set of extra constraints around it that make this a data definition and not a match. It has extended primitive types. You can actually say type int64. You can say type decimal. You can say type datetime, right? Which is what we all deal with. We don't want to do a string with a format and all these things. And decimal is tricky. Why is decimal tricky? Because the number in JSON can only accommodate 2 to the power of 53. Because, see, you were expecting that to be different. Because in the spec, in the JSON spec, it says this needs to be able to fit into an IEEE 754 double. The double can only have an integer portion of 53 bits. So you're factually constrained with this because implementations are allowed to use double as the backing type for number in JSON, and so therefore you can't fit any ints. So long int here and decimal here are defined as underlying, as encoding as string. And then there's type annotations, like precision and scale for decimals, and some further annotations that are also useful. Again, this looks like JSON schema, but it has more depth. Then we have so-called reusable types. $ref is not allowed to point anywhere outside the document. If you want to go and have a type that you want to refer to, you have to stick it into definitions. And that's how that relationship works. If you want to have external files, you can get them, but you have to $import them. So there's an explicit mechanism to $import those files, and then you treat them as if they were local references. There's namespaces. So in definitions, there are non-schemas, which don't have a type, and schemas, which have a type. You can create folders, if you will. Inside of the definitions part, those are namespaces, and then you can go and put types in them. That maps super cleanly into every module type namespace system that we have in programming languages. Then there's $import. So with a $import statement, where's my thing? Where is it? Here. So there's a $import statement where I'm taking the definitions from this file and I stick that into the people definitions, into the people namespace in this file. And then once I've done that, I can go and refer to it like in the people address, because that's kind of what's mapped from here. So you can import straight into a namespace, a namespaced file, and import the namespaces outright, or you can go and slot basically an external file into a namespace inside of your file and then refer to it like this. Then I actually have inheritance in a very simple way. You can define abstract types, and the abstract types are basically just templates for common properties. And then you can go inherit those things by using extends. And so extends slots these properties into this type. It's not allowed, though, to reference the address space directly. So you can't create a property with the address space. You have to go and use the concrete types. And if you just want to have a referable address object, then you go and extend the address space, and with that make it usable. But that solves the problem of I have these repeating things which need to be everywhere, right? I want to inherit those, but I don't want to force an inheritance mechanism on a database, which doesn't have them. But I need to have, every table needs to have all the same properties. Then I have a mechanism called add-ins, where you can go and add a definition that you made, like these delivery instructions. And I can go and slot, I basically can go and slot those delivery instructions. I can go and slot them into a concrete type. So this is a schema, this is using the addresses, or this is based on an address. There is a plugin definition that's here, and I can go and then just $use those delivery instructions, and then that slots the instructions into my type. So that's an extension mechanism, basically, and I'm using that extension mechanism to allow for the specs to be imported and put on top of each other. Alt names allows for different serialization instructions. So if I want to serialize person as person_data in JSON, I can go and specify that. And then I can also give alternate names, like display names, effectively. First name, Vorname. Here in German, I can go and basically just go and define those. That's an extension spec. Then I have scientific units. So you can annotate currencies. You can annotate units. All of that in the interest of just making the data better. They have no structural function. They basically just say, this is what this is. And then all the validation stuff that you know from JSON schema can be added by importing, by $using an extra spec that's the validation spec, and the conditional composition spec, which you can also add, and then you still have the all-offs and the any-offs and all these things. But the core spec and these core layered specs are there to just build better data structures. So that will be submitted into the IETF. You can look at this now. You can ask questions. You can make contributions at json-structure.org. I believe this will be useful. And the specs are actually much better to read than the JSON schema spec. Because we need to fix the data quality problem, and we need to have a toolable JSON schema. All right. Advertise. Advertise is a tool that I built with a focus on Avro. This is going to learn JSON structure too, which tries to deal with the fact that you have a data definition that comes from the left, and then you need to go and put that into a database later, for instance. Advertise is a command line tool that also has a representation in Visual Studio. We're going to take the Visual Studio version. So if I have here, not that. If I call advertise, I'm kind of standing in the way of this thing because this thing is just standing in the way of everything. So it has a bunch of options where you can go and do schema translations. And I'm going to do some magic things here that you never thought possible. Here's an ASN1 schema. And I'm going to go and right-click on that ASN1 schema, and I'm going to say, where is it? I'm probably not going to right-click on the ASN1 schema. Let's go and do Proto works. So here's a Proto schema, and I'm going to go and convert it into an advertise schema. Okay, it's asking me. It's going to take a second. Okay, so now we created this into an advertise schema. The advertise schema is an Avro schema. Advertise schema, but it's an annotated with a few annotations, so it's not strictly Avro. We're going to take the JFrog pipelines. JFrog pipeline, this is taken straight from schemastore.org. JFrog pipelines is quite the pig. It's a little long. It has how many lines does it have? It has like 11,000 lines of definitions. And then it has things like, where's my favorite enum? There's my favorite idiom. How was that? How do you love this one? Okay, so I could obviously do a talk for 4 hours about advertise. I'm just going to go and show you a few things here. So I'm going to turn this into an advertise schema. I need to have a namespace for it. Okay, nope. Okay, J for pipelines. It's going to take a moment. It has to think. Here we go. So, and now we have a 14,000 lines Avro schema that is exactly equivalent to that JSON schema with all the circus. So you're now, what am I going to do with Avro schemas? I'm gonna go and pick another Avro schema of the much beloved Northwind database. And I'm going to go and right-click this and say convert to. Now, if I have an Avro schema, of course now, because that's my pivot point, I have more options. So I can go and say, I want to have a SQL schema. And it's going to say, which flavor do you want? We're going to pick Postgres. Do you want to have cloud events columns added to the SQL table? Yes. Okay. So, and then it's going to go and drop a Northwind SQL file, and here you now have all of these definitions that were in the Avro file as a SQL database. Because we need to build end-to-end pipelines, and these cloud events types here are injected because the assumption is that when you flow data through a pipeline, you also want to capture the event metadata. But you don't want to have the event metadata necessarily in the face. But you need to capture it for each event, basically, that the data came in with. So that's why I'm also allowing you to go and generate these things. It can generate into NoSQL databases, into SQL databases. It can go and create code. Oh, wait, let's do this one thing. We're going to say convert to. I'm going to take C#. I work for Microsoft. Yes, yes, yes. Here's a C# project that has all that code based on that definition. It does that for Go, it does that for C++, it does that for all those things. Because it's important to have those structures available, when you have to find them somewhere, you cannot have them locked into a particular schema. If you start with Proto, okay, that's a decision you make for one path. But what's with the rest? So Advertise is aiming at just liberating your data definitions from one format and just turn it into others. And it's using Avro schema as the pivot point. And I will evolve this so it can also obviously use JSON structure, which is very new, as the pivot point, which is then going to be even better because there's more richness in that tool. So Advertise, there's a JSON, there's a VS Code extension, and there is the tool, all free, written in Python. If you find bugs, you can give me PRs. Multiplexing. Just going to do a time check. I have like 15 minutes left, I think. Oh, it counts down. I have 16 minutes left. Multiplexing, I talked about that earlier. So you want to make sure that the data that you send through an event pipeline, that you can go and tell apart which events you're sending. You want to be able to go and send multiple kinds of events through a single topic. Because a topic is a route. It defines how do you get data from A to B, from this module to that module. It is pretty silly to create 10 routes between two modules just because your code is too simple to demux. So demuxing is very easy. You look at a field. The field has a particular value. You go this way. The field has a particular other value. You go that way. That is relatively simple, but you would not believe how many Kafka topics people are using, or they are, oh my God, using partitions to go and send multiple types. that is the worst. How do you do that? We have defined laborious conversations for 2 years, 2.5 years actually, and then finished finally in 2019, I think, version 1.0 of the Cloud Events specification. And the Cloud Events specification, I've been one of the major contributors to it is getting adoption. Standards take a long time to gain a foothold, but it's being used more and more and more. And I see customers coming to us already and they say, I'm using Cloud Events. And I'm like, I'm very happy about that. What does Cloud Events do? If you were here for the keynote, you know the problem. We need to have a separation of data and of metadata. And what we've done in Cloud Events is we sat together with AWS and Google and PayPal and numerous other companies, 40 companies in total. And we have basically said, what is an event? That's kind of where we started with. We wanted to define what is an event. And then after we decided what an event is, we had long, fun, interesting discussions which went into history and whatever to figure out what does that event, what does a standard for event needs to contain. We ended up with 7 attributes that answer questions. And the questions are, well, first is the spec version, 1.0. This will, as long as I'm in this project, not change. We will not make another revision of this. This is going to stay stable. We have a top-level CNCF project where we have made a pledge to not do a new release. We will make amendments and errata, and we will create extension specs, etc., but the core spec is sacred because stability is important. Okay, the questions. Which event is this when you look at it? Is the ID. What kind of event is that? That's the type. That's the multiplexing piece. Where did that come from? That's the source. Who raised that event? That's typically the place that you subscribed on, right? Or that is raising those events. Subject is what is that event about? So you have a machine that's giving you event. You've asked a machine to give you event, so that's the source. And then there's a thing inside of that machine that event is about. So you have a car, and inside of that is an oil pump. And so the oil pump event comes from the car, but it's about the oil pump. Source, subject. Very easy. Time, obviously, when was that event raised? Data schema is a reference to the data structure that's inside of the data field. And then data content type also describes what's the content type for that data field. What's important is that JSON, even though this is what a cloud event looks like, it's always shown in JSON. It's important because it's just convenient. It's important that it is a encoding neutral and also transport neutral model. It's just an envelope definition. In the end, it's just these 7 attributes with mapping rules. There's a binary mode and there's a structured mode. And the structured mode is what you're seeing here. This is the structured mode in the event format for JSON. There's an event format for Avro. There's an event format for XML. There's an event format for Proto. There's event formats, how you can go and render a cloud event in these various formats. If you build a bespoke event format, you don't have those. And there's also for binary, there's protocol bindings that define how does the cloud event map onto an HTTP message, how does it map into an MQTT message, how does it map into an AMQP message, so that the payload stays the payload, right? So the payload is then just the HTTP body, and the attributes of the cloud events are then being mapped, for instance, into HTTP headers. So all of those things are also part of the cloud event spec, not just the definition of the 7 attributes, but all these other pieces too. But this is how this looks. Ultimately, you have a data section, and then you have all these all the metadata on the side, and the metadata is completely extensible. When you use cloud events, it's going to be good to be able to describe those cloud events. to be able to say, my application is raising 7 kinds of cloud events. It has an endpoint that is raising those, or I'm providing an event sink that can take these 7 kinds of events. And when we had released the cloud event spec and we saw the first implementations, what people did is they wrote a document in their docs and said, we accept these cloud events, and this is what the cloud event will look like. But there was no formal definition for them. So we're like, it's probably bad. So we started with an effort called Cloud Events Discovery. And in Cloud Events Discovery, we then said, we have to go and find a formal way to go and define those. And we kind of oodled around and ended up with a separation into schemas for data. And the data schema field kind of refers to that. A definition for events that defines basically which values do those cloud event attributes need to have, and are there any extensions? And then a notion of endpoints, which means what is the protocol of a sink, and how do I do the mapping and formatting and all these things? Like we had these 3 registries. We started building them, and then we ended up in a situation where like, now I need to go and do the same mechanism like pagination or filtering, whatever, in 3 specs. And we're like, that's a little weird. So we then said, no, we have to go and refactor this whole thing. We're going to create 1 core spec, and then these 3 registries that we're building become effectively the implementation of those core specs. Then we ended up being a model, and then we ended up with a kind of generic metadata registry, which works really well for eventing. X registry. And this part, yes. Okay, so I will show you a few things. Let me start with, not this page. Let me start with this page. So there is a repo that is the X registry repo. There is a page that's called xregistry.io that explains the basic story and what that is for, and has links to those specs. I have vibe coded this page because the previous one was pretty terrible, and like, please agent make this prettier, and just said, yeah, here is prettier. So this is the spec, or the spec repo. We've been working on this Microsoft, SAP, Solace, PayPal, Google, a bunch of people from companies which are kind of interested in that problem. And we've been working on this for like 3 years. And what we came up with is this model where we have an API and documents. And I'm going to show you that in my in this repo. That's why I wanted to go here. I'm going to show you a few examples. I'm going to show you documents first, and then we're going to go and look at the APIs. I will pick the light bulb, because that's kind of the most obvious one. And now I want to make this go away, and I want to make this a little bigger so we can all see. Okay, so this is an X registry. X registry has a fixed structure. It has groups, or it has a group. It has a group type. It has groups, and then it has a resource type, and it has resources. And that's the common structure across all of them. And here in this particular case, we have the model for message definitions and the model for schema definitions. So here's a message group, and the message group is called fabricam.lumen. Inside of that fabricam.lumen message group are a number of messages. Think of a message group as a thing you can go and pick up from the registry. You can go and pick up the pointer to that message group, and you can hang it on your topic. And when you do that act, when you do that association, everything that is inside of that group is associated with that topic, which means all those events that are in that group can now flow on that topic. That's kind of the concept that we have here. So we have messages, the fabricam.lumen.turned on, an envelope. The envelope type is Cloud Events 1.0. and then there's envelope metadata. You must have an ID. The type is going to be fabricam.lumen.turned-on. It has a description. The source is a source of an event, has a URI template that needs to be filled, and that's also how you can interpret this. You have to provide the type, the time, and the content will be application JSON. You have a data schema format that is Avro in this case, and the data schema URI. The data schema URI you see here has a pound in front of it that resolves into the same document. So if I scroll down, we're going to find the root of the schema registry. And the schema registry, Fabricam Lumen, has schemas in it and has the turned on event data has versions, and it has right here only one version, but you can go and maintain however many versions of that schema in here. So that's kind of this file for a cloud event definition, set of definitions with JSON, with Avro schemas. I can also go, because we don't only have cloud events, I can also go into the smart oven here. Again, cloud events, but it points to the schemas turned on event data. So so far that's very similar. But you see the data schema format is XML schema, and those XML schemas are also embedded here, right? But they're text. Because it's like we don't care about what the schema language is. And then you can also, these were two cloud events examples. You can also define things like MQTT. So here, it's an MQTT endpoint. The MQTT endpoint points to the message group that is also specific for MQTT. So you no longer see the envelope, but you actually see the protocol option. And in the protocol option, you say, this goes to this topic, this has clause 1, this has the retain flag not set. This is all defined in the specs. So you can do this for AMQP, you can do this for HTTP, you can do this for all kinds of protocols. So you can either stay neutral in cloud events, or you can go down to effectively the wire and define this for Kafka, whatever, right? But there's always a way to kind of group a set of message definitions, which then link back to the URIs. That's the thing that we build kind of for messaging, so that you have a formal way to go and deal with this. I have here a unified namespace and X registry at Contoso AutoWorks document. I have negotiated this document with ChatGPT for about 2.5 hours. Along the standards by Volkswagen for their factory layout. That's very long, many documents, and I said I need to have a substrate of this, and then we need to go and have a representation in the MQTT unified namespace. That's the hot thing in manufacturing right now. And so we talked about what exists in this factory layout. So there's stamping cells, laser cells, welding cells, painting cells, oven curing cells, paint infection cells, axle assembly. There's all these things that are happening. And then there's kind of a clear description of here's all the telemetry events that are coming out of this. So we talked about this at length. There's a lengthy document that I didn't include, but kind of it talks about all these things. And now there is this. What comes out of this is this definition of what that unified namespace looks like in X registry format. And as we started, I threw this into this tool here, and it ran into an error, and it stopped. That's fortunate. Okay, well then we're not going to show that part. If this works, this definition is so good and so constrained that the code generator, without knowing more about X registry, can actually build an emulator based on this, if it works. I did this 2 days ago with a colleague, and I said, I got to show you something, and he just basically fell off his chair, because these LLMs really like constraints, and these are capture constraints. So you just saw the files. These files are the way how you can go and communicate complete event streams to others, and where you can also base code generation on top of. Now, there's a site that is temporary. Don't rely on that existing. mcpxreg.com that has a visualizer in it. And yes, I can go and find my message groups. Oops. Wow, he reloaded the server. That is very evil. We can go and get the schema groups here. And so I can go into schema, and these are the schemas that I have. I can get to the details. So here's my schema document. This is a visualizer, effectively, of my, my registry. But you'll notice that there's also some other stuff. Because what's interesting is that when you think about just in general metadata of that sort, then you'll find, well, we can do schemas, we can do message definitions, then we can certainly also do APIs. And so here's a few API providers, and here you have APIs from adobe.com, and here's an open API file in the same way. Now, I can also go and in the similar way, look at other registries. So, for instance, let's say the node registries. So this is npm. Or I can go and take a look at, I need to go into the navigation right, .NET. And this is the NuGet ecosystem. I can go and click on something. You see all the versions that thing has had. Right? This is a NuGet package. Because in the world where we're now having all of these agents and MCP servers, these MCP servers have links to objects, right? There's a repository, and there are dependencies that those things have, and those dependencies kind of cross-link to packages and all these things. So you have a metadata graph, effectively, that you want to go and explore. And having just one API to go and provide all those access to those resources is going to give you a better chance of success. So it's schemas, it's endpoints, it's messages. For us as messengers, right, eventing people, this is kind of the core piece. But Xregistry as a spec is useful for all of the other things, and so one of the goals that we have is to establish it really as a metadata graph foundation, because it can go and cover all these other aspects as well. All right. Yes. And so in closing, I just want to show you quickly how this materializes in actual product. And I'm going to give you a preview without telling you secrets, but kind of showing you what that will look like. So I said in the beginning, we're building both Azure and Fabric. And this is kind of real-time intelligence. That's our eventing pipeline. And I'm going to show you the pipeline for USGS. No, I'm going to start here. So this is the USGS Water Services Instantaneous Value Service, a visualization of it. I'm collecting data for the last, half year. I've been also doing that for NOAA, the National Oceanic and Atmospheric Administration. Those APIs don't work so well anymore. I don't know how that could be. And a bunch of other public data sources, GTFS and whatever. This still works. And so these are effectively the stream flows, gauge heights, etc. In Connecticut, I have this for the entire United States, and this is basically just the data that's available now for Connecticut for this particular hydrological unit that I've been picking. There's a bunch more. It's pretty significant amount of data that's being streaming in. How do we deal with that? We have here an event stream, and the event stream is a built-in capability, and that event stream is when you create an input into the event stream, so-called custom endpoint, you get configuration data for Kafka, for event hubs. You basically get a connection string or the parameters for your client, and then you can go and push into this, and then you can go and then route this into a database, into event streams. And when you have the events formatted in the right way, there's a basic straight path into the database. And then in the database, we're actually demuxing. There's a script that goes and demuxes those events into the various tables, and that's what happens continuously here. So there's currently roughly 300 gigabytes of data that has been ingested, and the ingestion basically happens kind of 1 million rows kind of every day. For this one, here there was a little bit more. So this keeps going. And it's a streaming database, and it's for me personally, KQL. So that's the Custo database, or the KQL database, called Event House inside of Fabric, is the coolest event-oriented database that exists, mostly because it's also how we run Azure. So Azure monitoring, all the internal diagnostic tools, all are operating on top of the Custo database. It's a giant infrastructure, and so you gotta get your piece here, and it's really good with events. And so that's how that's getting captured in here. And then lastly, let me just show you where that actually comes from. So here's the real-time sources repo. That's public. And the real-time sources repo has all of my sources. Let me just go here. All of my sources that I have. So there's a mode S for dump 1090 for catching ADS-B data from planes. There's NOAA, the NOAA API. Pegel Online is the German water services API. There's a generic RSS feeder. And there's the USGS feeder. And then there's a GTFS feeder for general transport feeds. And all of this is done by, there's containers that are pre-built that are in this repository, where you can which you can basically just start with Docker. And then you just basically provide the parameters for your Kafka instance or for your Event Hub, and the things just start pumping the public data. So you can just go and run those things. And so in particular, this USDS thing, as all the other projects, have an XReg definition. So as you are already familiar with, so USGS, sites, messages, all those messages are being raised. Those are effectively declaring these are the events that my bridge is raising. And then there's a code generator that I'm using. I'm currently revamping this, so I can only show you the effects of it, where there's a producer, and it has a Kafka producer in it. And that Kafka producer here is a Python file, which then basically goes and gives you ready-made functions, which is send USGS site, send USGS site time series, which is basically taking all these definitions that I have defined. Here's the event producer, the next event producer. All these definitions that I've been defining turns that into normal methods which take the data, and they deal with all the eventing stuff all by themselves. So that's stuff that you're going to see also in the X-Registry repo as a code generator that you can go and use for these things. So all of the things that I showed you many of them are early, but all of them are going to end up in open source in the X-Registry project. And I know you stand there because I'm over time. But I'm not over time yet. I still have 50 seconds. Yes. Yes. Oh, that's true. I don't. Okay, well, that's my last slide. I'm sorry for taking more time than I should have, but I thought it was hopefully useful for you. And it was a pleasure to talk to you. Thank you.